This is Matthew Topol, giving my talk for Snowflake Build Conference about faster data transfer utilizing ADBC, Arrow database connectivity. And for precisely what that is, I will get to it in a moment. I am a co-founder of company or startup Columnar. I am also a Apache Arrow PMC member and also a committer on the Iceberg project as well. I also wrote the book on Apache Arrow. I get to say I wrote the book on it because I did, in-memory analytics with Apache Arrow. And I am the primary developer on the Go implementation of Arrow, and I contribute to a bunch of other Arrow projects. And I'm also the primary developer and creator of the Go implementation of Iceberg. And so that's who I am. And let's quickly, before we go dive too deep, I'm going to give you a quick primer on what Apache Arrow is, so we can all be on the same page about what we're talking about. And so Apache Arrow is a column-oriented in-memory data format. It's spec. So the spec itself is has implementations in crap ton of programming languages, whether you're talking about Go, C++, Python, Ruby, Rust. It's implemented in any language you want to utilize. And the point is that the data in memory, the way the bytes are laid out, is identical to the way it's laid out on the wire. And that way you get to avoid that pesky serialize and deserialization every time the data goes from one system to another or from one process to another. You can just take the raw bytes as they are and just hand them off, and no conversions and serializations. If you're in the same process, you can even do it zero copy or even shared memory. The point is that it makes this data transfer and communication significantly faster by eliminating extra copies. Now, it's also, as I said, column-oriented, which means it is very, very suitable for vectorized operations, aggregations, and analytics. Now, if you're not quite sure what I mean about column-oriented, which is very important for this talk, let's give a very quick rundown there. Is when we're talking about a table of data. Traditionally, you have your row-oriented buffer of memory, where we store the values for each row as contiguous chunks of memory, and you get column A, column B, column C, then row 2, column A, B, C, so on and so forth. If we're talking about column-oriented representations, then rather than sticking the values for one row as a chunk of memory, you stick the entire values for one whole column as chunks of memory. Now, the reason why you want to do this is to improve I/O. If you want to, say, filter a table based on, in this case, maybe you want to only look at the rows where the year is in the 1900s. If the data is stored in a row-oriented memory buffer, you have to read every row and every column to find the values, because you have to jump around through memory to get to the years and check them. If the data is column-oriented, you can just read the 1 year column, that one chunk of memory. You can even do it in one big shot, and then use the result to then filter other columns. The point here is that you can reduce your I/O, you can reduce operation time, and you can benefit from compiler optimizations such as vectorization and single instruction multiple data SIMD, which require the data that you want to operate on to be in a contiguous block of memory. And with column-oriented memory, it's already in that contiguous chunk. So now that we're kind of on the same page here, very quickly rundown of the Arrow being a data format and column-oriented memory and why we like it and benefits of operating on it in data systems. Let's talk about actual data transfer with databases. Now, currently, and as it has been for the last 20, 30, 40 years, if you want to interact with databases, you're probably going to use ODBC and likely JDBC if you're using Java as your way of talking to your database and sending your SQL queries. And the reason Now, what these are, if you're not familiar with them, is a single API that your application can code against, and then you swap out drivers that implement the API, and the different drivers have all your specific behavior on how you talk to the individual databases. And this is great for an application that wants to talk to a lot of data systems, because then you don't need bespoke implementation for every single data source in your application. You can use the one API and just swap out your drivers. And when we look at it in practice, it looks kind of like this. Your application will use the JDBC or the ODBC API to submit a SQL query. Your driver that you loaded for that database will then translate the query into some database specific protocol and send it across. And then the query will be executed by the database and results will be returned in some database specific format. At this point, the driver is then going to translate the results from whatever the format the database gave it into the format required by JDBC and ODBC, which are row-oriented APIs. And then finally, the application is going to iterate over those result rows. And nice, simple and straightforward, albeit a bit, extra work going on in modern systems. And I'll explain. Now, there's pros and cons to ODBC and JDBC. One of the pros, one of the benefits is that they are not going anywhere. JDBC and ODBC have been around for decades. And while the specs and the APIs have expanded, in general, they haven't changed that much. And whether you're using Snowflake, whether you're using Postgres, various LTP, transactional applications, if that is what you need to do, you need to make row by row queries, transactions. ODBC and JDBC are the way to go because, not to mention the difficulties with actually installing drivers because they're a mess, but, you can be sure it'll work. The problem is that the overwhelming majority of modern analytic data systems, like Snowflake, like DuckDB, like ClickHouse, like BigQuery, are all column-oriented internally. And the reason for this is everything I just said a little bit ago. The improvements for vectorization, the improvements in performance, I/O, the whole nine yards. All these analytical systems are column-oriented because that's what is the way you make a performant analytic data system nowadays. It takes advantage of advances in CPU architectures and so on and whatnot, which is why row-oriented operation of computation is just slower if what you're trying to do is aggregations and analytics. Now, there are some libraries like TurboDBC or Arrow JDBC that attempt to perform some of these conversions, or at least reduce those conversion costs for you. But ultimately, if you're using ODBC and JDBC and you're talking to one of these column-oriented databases, which is most modern ones, you're paying a huge cost to take this column-oriented memory, transpose all of your data into rows for your ODBC and JDBC, and then we're going to transpose them all back into columns for your data frames and your visualizations and other interactions. Now, when I say transpose, that's copies. You're converting and copying the data, which is expensive and requires extra memory and so on and so forth. If you want to avoid that transpose and copy and cost, most of these systems have their own specific SDKs for that system that will let you avoid some conversion costs and improve performance in some ways. But then your application has to manage these complex integrations with all the different connectors. I mean, look at DBT, look at Trino, look at Presto, look at all these systems that try to eke out the extra performance and have to have, hundreds of connectors to different systems just to try to avoid ODBC and JDBC because they're slow. And they have that reputation being slow. And of course, the point of all this is there's a better way. Arrow Database Connectivity, ADBC. It is similar concept to ODBC and JDBC. You have a single API that is the client interacts with. Your application talks to one API. But instead of being row-oriented, the data that comes through the API is column-oriented using the Apache Arrow data format. And so if we look back at our diagram from earlier, It works in much the same way. Your application will now use the ADBC API to submit a query. You have loaded a driver. The driver will then translate the query into whatever database-specific protocol is necessary, and the database will execute your query and return the results. Now, if the results come back and they are already column-oriented, ideally already in Arrow format, then there's no translation, there's no copy or conversion for the driver to have to do. It can just forward the results on to the client, zero copy, no conversion, just boop. It makes it significantly more performant, which I will show you in a second. Now, of course, if the data is not already in Arrow format or not columnar, like say if you're talking to Postgres, we have Postgres ADBC drivers, because then the driver can just do the conversion for you. And the reason why you want to do that is because it means that your application can still have a single API to code against, and it's not having to manage multiple separate complex connectors. You can just swap out the driver as you need it. And also, the earlier the data is in Arrow in your system, the better off you are for all the downstream processing. And then finally, of course, the application can then iterate over a stream of batches of Arrow data. Now, obviously, I'm not expecting you to take my word for this on its own, because the entire purpose of this Snowflake build conference is demos and code. And so let's see this in action. Now, I didn't show you the link to where this demo code is, but for now, we can look at a simple Python script. Now, I'm going to show you this example in multiple languages to prove how this is completely language agnostic. But so if we look at our simple Python script, we have our basic Snowflake account information, the account, user, warehouse, role, and I have my path to my JWT private key. And we'll take, 100,000 rows to fetch. Now, if you look at the ODBC implementation, nice, simple. You have your connection string, the DSN Snowflake, the account information, telling it to use the JWT for authentication, and so on. Straightforward. And a simple select query to pull from the sample data, the sample TPCH table that Snowflake injects in all your environments. And we'll start off with 100,000 rows. We'll fetch a list of tuples, which is not the most conducive to ETL post-processing, but we'll get to that. We'll print out how many rows we fetched just to prove it, and how much time it took. Now, by comparison, ADBC, nice, straightforward, very simple. Import, instead of PyODBC, we'll import the ADBC driver manager, set up our connection options. You can see that they're exactly the same as we were using for the ODBC connection string, the Snowflake account information, the location of the private key file, and so on. And we will use the same select query from the same table. But this time, we're also going to fetch it as a polars data frame. Now, if you're used to doing data analytics or data manipulation, data science, you'll be familiar with using polars and data frames and operations in that way. And you'll know that this is a much more conducive format to interact with. Now, the reason why I'm going to do this is because since ADBC already returns Arrow data, and polars is already Arrow under the hood, there's no conversion going on. It's just wrapping it. So it's just, it's free, except now it's already going to be in the format that is easy to utilize whenever we want. And then, of course, fetch number of rows printed and the timing. And finally, we'll run ODBC, then we'll run ADBC, and then it will go. Now, it's important also to keep in mind that Snowflake, when you run a query, if you run the exact same query afterwards, the data is cached. It doesn't rerun the query, it just sends you the cached data. So first, we'll look at ODBC. Took 5.3 seconds versus ADBC taking 1.96. But again, we want to not deal with that cache. We want to make sure it's using the cache only and not timing the cost of the execution too. So we can see that when we go back to the cache, we can see that it dropped that 5.3 down to 2 seconds, but ADBC is still faster and already dumping it into a format we can use. But what if it was instead 1,000,000 rows of data? Because the more data you're passing through, the bigger the benefit you're going to see here. So switch to 1,000,000 rows. And we run it again. You can see it's taking a bit because ODBC can be very slow when you're dealing with this much data. And so it's running. And yep, ODBC is taking a while because it does. 12.9 seconds versus 2.8. Now, just to not make sure we're not dealing with the cost of the calculation, you want to just use the cache. We'll run it again just to be sure. And we'll see. But notice that when we went from 100,000 rows to 1,000,000 rows, ADBC didn't change much. We went from 1.9 to 2.8 seconds, and look, it's still about 2.9, and ODBC is still 8.4. So you can see there's a huge cost in ODBC that you're dealing with in that conversion. In this case, converting it to Python data types, actually, and lists of tuples. Now, of course, we also can do this in Go. Now, same idea. We have our Snowflake information. We have 100,000 rows to fetch. You can see the same query. And we're using connection string, ODBC, nothing different than we did before. And then ADBC, same as before. We have our same options, same query. And so let's see how we do. And so we run it. And we see that ODBC for 100,000 rows took 2.3 seconds. ADBC took 1.7 seconds. And if we bump that to 1,000,000 rows, because we like doing our comparisons, we can show once again, like I said, the more data, the more rows we deal with, the bigger the benefit you see. ODBC took 4.05 seconds. ADBC took 2.15. Nearly twice as fast. And again, the big benefit, the big reason for this difference in performance is that we're bypassing that conversion cost and we're bypassing that transposition. But not only that, not only is it faster, it's already in a format that we can operate on. And I'll get back to that in a second. Last demo of the same thing. This time we're going to use the R language. Now, first you have to make sure you run the install that packages files, but we do that. And you can see the options are all the same. Of course, we need to do at the same server. We need to do that. And finally, we can then run R. And see the same result of, I forgot to install the R packages. My bad. Oops. So you can see how I do this. I just install the ODBC package. It wants me to select a mirror, so I do. Go. And then we're going to also install the ADBC package from the driver manager. And then we'll rerun that. Now, in the meantime, while that does its thing, one of the other things we can point out here is that you can also leverage ADBC for bulk ingestion and bulk inserts, especially between two different drivers, two different systems. So in this case, we're going to compare using ADBC with Snowflake and with a local DuckDB. And what we're going to do is we're going to fetch that same list of rows, and we're going to insert it into DuckDB. Let's install the ADBC driver manager while we wait. Yep. We're going to insert it into DuckDB in memory, and then we're going to select, from it to just verify that it actually did in fact insert the data into DuckDB. And you can see how simple this is because we take our cursor of the execution, which is going to be a, a stream of Arrow record batches, and we can just pass that record batch reader directly into the ADBC ingest function for DuckDB. And you can see how simple it is. Just pass, because it's a stream. Not only is this efficient, it's also going to ensure that we're streaming the results. It's not even going to use all of the memory at one shot, because we're not reading the entire Snowflake results set into memory first. It's a stream of data going from one to the other. And so we can do pixie run Python, and we can run the integration test for ingestion. And we can see how fast it runs. Now remember, we're grabbing 1,000,000 rows, and we can see that we ingested 1,000,000 rows into a local DuckDB in memory. You can see it happened. You can see that we validated that we got the right columns and data. You can see the types are even preserved. Decimal 38, decimal 12. The types are preserved as we go through, and it only took less than 4 seconds to download, to query, and then ingest 1,000,000 rows into DuckDB from Snowflake. And the reverse also works, because the only difference here is which one we connect to, right? If you swap the arguments, you swap which cursor we're using, the actual syntax doesn't change at all, as long as you have permission to create the table. And so, you can see right offhand the benefits of performance, benefits of usability of using ADBC over ODBC and JDBC. Now that we installed the packages, we can run the R script like before. Live demos never go perfect, right? So we can run it using, we're using 1,000,000 rows. You can see ODBC 4.8 seconds, ADBC 4.5. Now you can see that a lot of that is probably to do this conversion to the Tibble format. And again, the more rows of data, the larger the data set, the bigger the difference you're going to see. If you want more information about ADBC in general, you can go to the documentation page, Arrow Apache org, ADBC. If you want more information on Apache Arrow itself, there's the link to the docs right there. Or you can also get my book. Yay. No, shameless plug. The book has examples in C++, Python, and Go. And there's a link to the book to purchase it right at the bottom of the slide. Even more fun is you can always use and test out the GitHub repo for the demo that I just showed you. The README has the instructions for how to, install the dependencies and use it and try it out. And you can give it a whirl and see how it goes. With that, thank you very much for your time. Thanks for watching this, and hope to hear from you. Try it out. Let us know how we're doing with ADBC. Thank you very much. Take care.